of getting down what everything looks like, so that way next week when we mix them all together, you guys will be able to tell how to do certain things. So when we're modeling with exponential, we're going to do two things. We're going to write equations, and then we're going to look at the tables like we've done before with the L1, L2, and do regression stuff. So it's really, really, really straightforward. For example, I'm pretty sure we did this earlier in the year as well when we did exponential. Y equals AB to the x. And we wanted to write the equation of that went through the set of points. 1, 6, and 3, 24. What we were doing here was very similar to, remember we did geometric series where we had to solve for, we did substitutions and solved out that way? It's kind of the same thing. We have our values of x's and y's, so we know that y has to equal a times b to the first power, and 24 has to equal a times b cubed. And what we do here is we usually get things in terms of a, because we just substitute back across. So I know that 6 divided by b to the first power is a. Take that here. And then I solve for b. Divide by 6 and take the square root. Now remember, these are bases and exponents. Are we going to have a negative base? So it gives you a b value of 2 and an a value of 3. And then you get your equation. Y equals 3 times 2 to the x. And I'm pretty sure we did that, right? Think, maybe? Maybe not. I don't know. When we did exponential, I think right when we got back from Christmas. Or no, we did that first semester, second semester, beginning of second semester. I thought. I don't remember. Yes, sir.
Well, it's b to the x, right? It's not a times b to the sum to the x.
Oh yeah, it's a times b to the x.
Okay.
B is to the x power. Because b is the base. How low can you go? Death row. Went back again. Is the rhyme animal. The uncannibal D. Public enemy number 1. By vote set free, and I've got none. Can I tell them that I've never really had a gun, but it's the raps that Terminator X spun? Yeah! There it is. Thank you. That's right. Bring the noise. Public Enemy. Or you can go with the Anthrax Public Enemy version of that too, if you like. You don't know that song? We will. It's like you guys also don't know LL Cool J is going back to Cali.
What is that?
Waiting what?
Why is A3?
Why is A3? What's 6 divided by 2?
Well, yeah, but we're getting figuring it out front.
Y equals
From the first equation.
the original equation.
It's a lot of substituting.
Couldn't you just put it into the original equation too?
Yeah, you can do that.
Okay.
Right? You want to do another one of those or no?
Nah.
All right. Let me show you the other one. Power functions. This is different. This is a little bit different. I don't believe we did this version of it. This one we're talking about finding the power function. And this is dealing with when you have the form a times x to the b. And don't worry, it'll tell you when to do what. You have an equation y equals a times x to the b, where it's like x is raised to some exponent, and we're solving for the exponent here, okay? You have your 2 ordered pairs again, 2 and 5, and 6, 9. Gee, what do you think we're going to do? We're going to substitute. 5 equals a times 2 to the b power. 9 equals a times 6 to the b power. We can do the same thing, get a by itself in the first one. 5 over 2b, or not 2b. You guys know I was going to say that, so I don't know why I wrote sub 1. Substitute across. Can I simplify the 6 and 2?
Could you do it the other way around too?
Yeah. You can. You can because it's the same exponent and all that. So it's just like x squared over x, like 2x squared over x. I mean, you can do the same thing. It works out. So you wind up with 9 equals 5 times 3 to the b. Oh no, what do I do now? What's that? No.
No, I can't.
Nope, can't log it yet. You're on the right track. We're actually first. Divide by 5. Get divided by 5 first. So now, is it 1.8? And now, like you were saying, now you log it. Remember when you do to get an exponent to pull an exponent out of thin air, you have to log it. Log base 3. Alpha Windows 5.
Windows
Zoom.
5.
Is it Alpha Window? Alpha Window. Yeah, it's my band. The Alpha Window 5s. And the magnetic zeros. What was the other one? I don't know. So it's log base 3 of 1.8 will equal your exponent. Some number. 0.535. So 0.535 is B, which means to find A. We have to go 5 divided by 2 to the 0.535. 6? 4, 6, 7? Which gives me a function of y equals 4.67 x to the 0.535. What's up? How are you?
Good, how you doing?
I'm doing very well. Good to see you.
Yes, sir.
What do we got here? He had already left.
You did already?
He's giving blood, so he's bleeding out.
Wait, so where are, you know, where I think this?
He's down the, don't need to go down the, you know, the dance room is, and you hang out there.
I don't know how to dance, so what, that's not my spot.
Me either.
I didn't make it.
Yeah, he's down there donating blood. And Miss Ron, they're making you take the part still, even though you've been dead and missing more school. Gotcha. You don't have to go now though. It's late.
Yeah.
Bingo.
Have a nice day, Mr. Murphy.
You too. Stay on track. I know it's tough. It's not how it's like. I think it's. If you've been out, you've been out for like what, 3 days, and you're making miss more school. That's good.
It's not 4.6.
It's
3.45.
3.45. I never said it was right.
Is that where you get to go? Sir.
Wait, so where is the 3.45 coming from?
5 divided by 2 to the 0.535. Or 5, yeah. That.
Are they always gonna be that ugly?
Yeah, because these are power functions. Power functions are usually pretty nasty because it's not like it's 2 times x squared and that's how you're generating your table. It's, you're going to get nasty numbers.
Okay.
Okay, so let's do the other stuff.
Yay.
These are the easy ones.
Oh,
Let's talk about finding exponential models. And when we're talking about exponential modeling and stuff like this, we're going to be given, especially today, what we want to do first of all is put this information in our tables. So clear your lists and let's do an L1, L2 of that.
How do you do this?
Second, and I'm in 4.
Yeah, clear your list of second plus 4. And then we go to stat. We want to edit. And we want to do L1, L2. L1 is 1 through 10. This is very difficult work. I should be a scientist. L2, 1.6. 2.7. 4.4. 6.4. 8.9. You guys are all probably waiting for me to move this thing out of the way.
Yeah.
That's why I no longer hear buttons being pressed. What if you're going too slow? It's just funny.
I know these are.
Oh, you're big headed.
Wow, this is daunting me like this. More points, please. That was an Oliver reference. I'd like some more points, please. Yep. That's what it is. What?
I don't think we.
I don't get it.
Oh.
You know, it's probably really funny to someone else.
Like your face?
Oh.
See, that was a compliment. It's funny to somebody else, not to us.
But you're still saying to someone who's very
He's saying
fun.
we.
Yeah, but not to us, though.
I don't get it.
Look at the bright side. Look at the silver lining.
Anyway, so we've got a data set, which means we're going to mess around with our window. Our window will probably go 1 through 10, and maybe 1 through 0 through 10 and 0 through 50, maybe.
Yeah, that's what I did. And it looks really cool.
For the lives, they go back.
Yeah, I would just go by ones.
Scale of 0.
Oh, oops. Oops. That'd be all sorts of messed up. Hey, look at that. Yes, ma'am.
Do you have to do it like one bigger than like?
You don't have to. Sometimes if you do it a little bit larger, you might see it a little bit better. But what they're doing here in the data set, even with the ones they're giving you, it's going to be pretty obvious this is an exponential. It's growing at a rather rapid rate. Okay. So here's what our scatter plot looks like. Pretty convenient that I was able to do it oh so awesomely. Shut up.
Just where we.
Yes, sir. Oh, I thought you were trying to make fun of me. I take that back. You got dimensions mismatch because you've done good.
Nice shot.
Look at your window. You have a maximum 1,000.
You had your scat plot. Is it scat plot?
Yeah. Oh, you actually have a 0 here. That's why.
0.
There you go. Yeah. He actually accidentally had an extra value in one of his L1 or L2, but it did not. He had a value in an L2 with no L1. So that's why he's getting a dimensional error. You were in the 35th dimension. 35th dimension.
Okay.
Isn't that the
What's up?
I think I can do it too.
What's that? I don't know. Huh?
I messed up because I don't know.
Well, calculator better. Let me see.
It's all I got.
So here's the deal. The trick for these, the trick for working with these guys is that you, oh, your stat plot's not on. There's a problem. The trick for working with exponential growth is that if you take the natural log, take the natural log of your y values. In this case, it's your L2. What happens when you plot your L2, let's see if we should be able to do this on the calculator with all of it at once. If we go back to our stat, we want to edit, and I want to make an L3. What I'm going to do here in this column is take the natural log of everything in the second column. So all I'm going to do is just take natural log 1.6, enter. Natural log, bless you, 2.7. Bless you. All the way down. It does take a little bit, yes.
Yeah, but I have to push more buttons.
Well, maybe I'll be nice and finally sign you out another calculator. Means you'll be on the hook for 2.
Hey, you don't have your own you don't have your own calculator.
We got stolen.
You think?
Yeah, I'm sure. It's been a bit long.
Okay. Now what? Well, we're going to go back and we're going to plot a second graph. What I want to do is go to second stat plot, and we're going to plot a second graph here. So go to plot 2 and turn it on. We're going to turn this on. But now we need to change our list. We want our X list to still be L1, but what do I want my L2 to be? I want it to become L3. So I change this over to, and L3 I believe is second 3. And that's how you change it to list 3. Everybody see that? Waiting. Go to, you want to go back to your second stat plot. Turn on plot 2. Where it says Y list, you want to scroll down, and now you want to hit second number 2. It's got to change it up. And now hit graph, guys, and you should get them both on there. Should work. What happens here, if we change our scaling around right, you'll notice that, oh, well, my calculator gently weeps. The natural log of that should always look linear. That's how you're able to distinguish if it's an exponential model. When you have your exponential hook, when you do it via the natural log, it should look like it is a linear function. If it does, that means it was. So when we get into these more next week, when you're just looking at data sets and you're putting them in your calculator, it's curving upwards, so it's assuming that's going to be an exponential, but to verify that it works out, it should look linear when you graph it via the natural log. That's the trick for setting up to see whether or not something's going to be exponential. Now, the only other part of this stuff is how do we write the equation? Well, what do you think you're going to press?
Second place.
Stat, calculate.
Right.
Which one is it?
X. Right.
X brag.
X.
X brag. X brag. Sounds German.
I'm glad I had that.
I don't even know what I'm talking about half the time.
Expert.
And you want to make sure you're at L1 via L versus L2, because those are what you're looking at. Hit a couple of buttons.
Oh, I can't change that.
And there's your equation.
All right, so mine's the same expert.
What's that?
Mine expert would be same.
Good. Okay. And that's kind of what the exponential stuff's going to look like. Okay. The trick for it is going to be, in order to decipher whether or not it winds up being exponential, is that when you take the natural log of your y values, it should look linear, and that's how you'll be able to tell. Okay. Scariness. I'm gonna use some problems. Give me I'll get you, I'll sign that out to you here in a second. I just want to make sure you're both taking problems here. So let's do
Pretty nice calculator. No.
Like if you have to do your character 3 times first number,
do those, please. Okay. There's two write the equation of exponential, and there's two power equations, and those three are just using the modeling function by using regression to answer some questions. I'm not going to waste the time of just having you guys put stuff in a table. You should be able to finish this.
Do you have a book?
Give me a second, I'll just put it up.
Okay.
What was it, 21 and 22?
Yeah.
And then 32, 33?
Yeah.
Is that okay?
54.
At least I got 54 on there.
Thank you.
Welcome. B to the 3. That.